Alright guys, for lesson 77, this quick little video, we're going to talk about units of mass and weight and how do we convert between the two, or for different units. So again, when you watch these videos, my intent is for you to take the notes down with me, pause it when you need to. If I'm going too fast, that's the luxury of this, and write down any questions you might have that you'll be able to ask in class. So on page 398 in your books, you'll notice a little table that's a table of equivalents for different units of weight or mass. Now there is a difference. Mass is the quantity of matter in an object, while weight is actually a force. That's the force that your body or whatever object it is exerts on the ground. So they're not technically the same thing. They get thrown around a lot as the same thing, but they're not. Nonetheless, that really won't affect what we do. But you should copy down the information from this table. And I've written it here, but you can see a lot better if you have your textbook open. And so why do we do this? Well, our goal is to be able to convert between different units of measure for specific values. Sometimes it makes a whole lot more sense to talk about how many tons a truck weighs instead of how many ounces it might weigh. Or you might prefer to talk about how many ounces of water you drank compared to how many gallons. You know, it's helpful to have different units for different situations. So our goal again is to be able to convert depending on what that situation is. So take for example my porterhouse steak here in example 1. It was advertised as a 22-ounce steak. How many pounds would this be? They advertise it in ounces. And that's because most steaks are usually less than a pound. I say most, and that's in general. But this particular one, the porterhouse, it says it's 22 ounces. Well, what if I wanted to know how many pounds this is? Because pounds is the most familiar unit that I have in my life experience. What do we do? So we want to think back to something. We go back up to the table where it said 16 ounces was 1 pound. So we know, hey, this is definitely more than 1 pound. But I'll ask a quick clarifying question. Is it more than 2 pounds? How do you know? Well, we have to think about something. If 1 pound up here was 16 ounces, and let me just remind you that an abbreviation here, 16 OZ, would be the same thing as 16 ounces, and then 1 we have LB. We have abbreviations for that, and there's probably a reason why we do LB. I don't know. It's not important right now. But my steak was 22 ounces. Do you think it was more or less than 2 pounds? So you'd have to think, well, 1 pound was 16 ounces. 2 pounds would be twice 16 ounces, or 32. That's right. So we could say, well, I know that 2 pounds is 32 ounces. But what are we doing here? We're thinking about the fact that 1 pound is equal to 16 ounces. So if you think about this fraction for just a minute, there are different units on top and bottom, but the top is equal to the bottom. And anytime you divide something by what it's equal to, or something by itself, aren't we going to get 1? Right? Well, maybe you get that. Maybe you're still confused about that, but I want you to think about something. How would we use that, right? Is this just something I wrote on the paper, or is this actually something I can use? And it is, of course, a second. We can use this, maybe not to get rid of that. It looks like a pizza stain. That's actually just highlighter. But what we're going to do, we're going to use this. This is called a conversion factor. Why do we have that? We want to convert 22 ounces to pounds. So we're going to start with my number, 22 ounces, okay? And I want to convert that. I want pounds. So I wrote equals over here, and then I've got a little line here. So what we're going to do, we're going to multiply by something that will convert 22 ounces to just pounds, okay? We know that there's 16 ounces in each pound. So watch what happens. I want pounds in my answer. So when I write this fraction, I want pounds on top, and I have to think about something. Well, I don't want ounces anymore in the answer, so I want to get rid of it. And what we've started talking about with fractions is that we can reduce or cancel out when you have something on top and bottom, because ounces divided by ounces is, again, it's 1. So 1 is going to be a very special number here for us. So 22 ounces, I'm going to multiply by the number of pounds and the number of ounces. Now, how did I know that? Well, that came from my table. 1 pound is equal to 16 ounces. Okay, so that's how many pounds? Well, it's just 22 over 16. That's not really the most helpful number for some of us. So here's another skill we've been working on. Let's convert that to a mixed number. 1 and 6/16. Because 16 will go into 22 one whole time, and I'll have 6 left over. So 1 and 6/16, some of you can already see, I can reduce those. Both of those are divisible by 2, so I can actually make that 1 and 3/8 pounds. Now, I would accept 1 and 6/16 because reducing is not something we've done a whole lot with. Nonetheless, what we've just done is convert 22 ounces to 1 and 3/8 pounds. Okay, well, what would happen if I asked you to go the opposite direction? Let me turn the page here just for a moment. What if I had said, I have 3.5 pounds of barbecue. My church just did a barbecue this past weekend, a little benefit. And we wanted to know how many ounces that was. So, how many ounces does that equal? Well, let's go back for just a moment. Let's look at what we did. We took our starting value and we multiplied it by a conversion factor. That conversion factor was really just copying something that was equal from our table. So it was 1 pound, which was equal to 16 ounces, and we got rid of the ounces. We wanted the pounds. So this time, we have the pounds, we want the ounces. So if we have the pounds and we want the ounces, again, all I did was write the question here. I'm going to take 3.5 pounds. I'm going to multiply by something, and you'll hear me say this in older math classes, a fancy one. We want ounces, right? So if ounces is the one we want, that's what's going to go in our numerator. And then, of course, we want to get rid of the pounds. And now we just have to think, well, what's the relationship between ounces and pounds? It's exactly the same as it was before. That will stay the same, 16 ounces in 1 pound. Now watch what we do. The pounds over pounds cancels out because we have the same factor on top and bottom. The ounces is the only thing that's left, which is what we wanted. And so then we're going to multiply. We've talked about multiplying whole numbers times a fraction, or fraction times a fraction. Remember that there's an understood 1 there, and fractions just multiply straight across. So 1 times 1, yep, that's just going to be 1. 3.5 times 16. Good opportunity to remind ourselves, how do we multiply decimals, right? The same way we multiply all numbers, we're just going to remember there's 1 decimal place in this particular one. It's the total number. So 5 times 6 is 30. You know what? Pause the video, see if you can get the correct answer here. All right, so hopefully you got 56.1 ounces. That doesn't make any sense, does it? 56.1? Johnny made a boo-boo here. Let's check my work. If you look at what happened, where did this 1 come from? I think I was thinking ahead. Going back through it, 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. Now we're talking here. 3 times 6 is 18. 8, 1. 3 times 1 plus 1 is 4. Now that makes more sense, and some of you might be able to say, yeah, I could tell because 16 times a half was going to be a nice even 8. Nonetheless, how do I know how many decimal places are in it? Well, there's 1 decimal place total out of these numbers, so 1 decimal place, I'm going to get 56 ounces. So we just use the opposite fancy 1, as you heard me say, to help us do that. Now, what if we start working with the metric system units? So we've got another part of the table where we have the metric system, which is based on the number 10. In the case of our examples, everything's kind of looking at 1,000. So there are 1,000 milligrams in 1 gram, 1,000 grams in a kilogram, 1,000 kilograms in what we call a metric ton, which is clearly different than a U.S. ton. Okay, but this word's important to make sure we know which one we're talking about. Okay, so you'll see a lot of times if you've had to take medicine before, it's given in milligrams because it's very small amounts compared to something that's given in kilograms, like the amount of weight a bridge can hold. But let's take a look at my example. Let's see if this little conversion factor thing still applies. So if I ran 4.5 kilometers and lost 1 kilogram of water weight, how many grams did I lose? How many grams was a kilogram? How many milligrams would that be? So I lost 1 kilogram, and I want, let's pay attention here, what I want grams. I want to know how many grams are in a kilogram. So we're going to multiply here. I want grams, so that's what goes on top. I want to get rid of kilograms, so that goes on bottom. See the cancellation? I'm setting it up to happen here. And what do we know? We know that there is 1 kilogram for every 1,000 grams. So I'm going to cancel out the kilograms, multiply as normal. 1 times 1,000, that's 1,000. The ones on the bottom, you can say, well, there's a 1 times 1, that's still just 1. But 1,000 divided by 1 is still just 1,000 grams. Now, hopefully you didn't miss this. There's a second part. Well, how many milligrams is that? How many milligrams are 1,000 grams? We're going to take 1,000 grams. We're going to multiply by something with milligrams. And then our answer is only going to be in milligrams. And I might run out of space here, so bear with me. Again, following that pattern here, I want my answer to be milligrams. So I might have to introduce another little piece of paper here. 1,000 grams times something equals how many milligrams? So slide it on over here. What do I multiply by? Well, I know that my answer, I want milligrams, so that's what goes on top. I know that grams needs to go away, so that will be on bottom. Now, if we go back to our table, what's the relationship here? Well, there's 1,000 milligrams in 1 gram. So we can represent that here. There's 1,000 milligrams in 1 gram. Now I'm just going to cancel where the G's are on top and on bottom. I know that milligrams is all that's left, which is what my answer says it's supposed to be. And then we have the 1 on the bottom. If you like to have that as a placeholder, 1 times 1 is just 1. 1,000 times 1,000. Oh, wow. Have we done multiplying by powers of 10? Yes, we have. You just count the zeros. There's 1, 2, 3, 4, 5, 6. So my answer will be 1 from the 1 times 1. And then I have 6 zeros that follow it, otherwise known as 1 million milligrams. So that's how we're going to convert units. And this is going to stick with you for the next several math classes. It'll also spill over into science. So good luck. Bring your questions to me.